time is weird. You may have heard that, and nowhere is this more true than near a black hole. These strange objects warp time to such an extreme that they're literally time machines, although maybe not the kind that you're hoping for. So here's what would happen if you fell into one. First things first, don't fall into a black hole. They're pretty bad. Even just being close to one can be dangerous. We know this because it's not just space that's warped around a black hole, it's also warped on the inside. The effect is called spaghettification. Basically, one side of you will be closer to the black hole than the other side. And since gravity depends on distance from a massive object like a black hole, the side of you closer to the black hole will be experiencing much stronger gravity than the part of you further away. This difference in gravitational pull will stretch you out, literally pulling you into a thin noodle shape. So if you were anywhere near a black hole when it ripped you apart, you wouldn't survive it. But let's play a fun little game. Let us pretend you managed to survive being stretched into a noodle by a black hole-esque gravity and just barely held yourself together and made it all the way to the event horizon. Now you can safely enter the black hole. It is only dangerous once you get to the singularity at the center or get spaghettified trying to get there. So you find yourself falling into a black hole, but you've made it this far, so you may as well take the plunge. What happens next depends on your perspective. If you want to see the future, then you should keep falling into the black hole. If you want to go back in time, then you should turn around and head back towards the event horizon that you just passed through. Well, technically, you can't do either of those things, but for the sake of fun, let's pretend you could. And we lines tell you why black holes are such great time machines and also why you probably do and want to use them. The idea that black holes are time machines comes down to their intense gravity. The closer you get to a black hole, the greater its gravitational pull becomes. Remember, gravity depends on mass and distance. And the greater the gravity, the slower time goes. So time slows significantly as you approach a black hole. But it doesn't just slow down, it completely stops at the event horizon. From the outside looking in, anyone who crosses the event horizon appears to freeze just before vanishing from sight. That's because the escape velocity at the event horizon is the speed of light. Nothing, not even light itself, can escape from beyond the event horizon. So once you cross it, there's no turning back. You're going into the black hole, and eventually you'll hit the singularity where all the matter in the black hole gets squished together. So if you were to fall into a black hole, from your perspective, nothing would happen. Your clock would stop ticking at the event horizon, and you'd appear to be frozen in time. To someone watching you from a safe distance, though, you'd seem to slow down as you approached the event horizon and then freeze entirely once you crossed it. They'd be seeing into the past. From their perspective, they'd be able to watch you fall into the black hole for the rest of your life, or at least until the black hole evaporated, which could take a really long time. Now, this is where the idea of black holes as time machines comes into play. If you decided to turn around at the event horizon and head back outwards, you'd be traveling back in time, or at least it would look like you were to the outside observer. That's because as you started to climb back out of the black hole, time would begin to speed up again. As you got closer and closer to the event horizon, your clock would start ticking faster and faster until you popped back out the same way you came in, and you'd be younger than everyone else. Unfortunately, this isn't really how time works. It's not like you can flip a switch at the event horizon that changes the direction that time is moving. The problem is that once you cross the event horizon, there's no coming back. Not only does your clock stop at the event horizon, but the event horizon is a one-way membrane. Nothing can get out. So if you wanted to travel back in time, you'd have to find a way to reverse the flow of time within the black hole. And we haven't figured out how to do that yet, if it's even possible. This means that the only way you can travel back in time with a black hole is if you manage to avoid crossing the event horizon in the first place. And there's actually a theoretical loophole that allows you to do just that. It's called a wormhole, and it's a theoretical passage that connects to different points in spacetime. Wormholes are predicted by Einstein's theory of general relativity, but we've never actually found one, nor have we ever confirmed that they even exist. If you did find a wormhole, though, it would essentially act like a shortcut through spacetime. This means that if you were to travel through a wormhole, you could arrive at a destination that was millions or even billions of years in the past. However, scientists think that wormholes might be extremely dangerous. Even if you did travel through one, it's likely that you wouldn't end up in the past in one piece. For one thing, if the wormhole connected to a black hole, you might just end up back at the event horizon you already passed through. And since you can't leave a black hole, you couldn't go back in time. And it's not impossible that the entire universe is inside the black hole. So you might just end up right back where you started. Then again, there's no reason to think that wormholes have to lead to black holes. If they connect to separate points in spacetime, they could theoretically lead to any location, perhaps somewhere far enough away that you'd be able to witness the Big Bang itself. If you want to time travel to see the birth of the universe, you'll need to make sure that you don't end up getting spaghettified in the process. And I think you should definitely subscribe to our channel to learn how that happens. Black holes have some other surprising effects on time. For example, they can create closed timelike curves, which are paths through spacetime that loop back on themselves. If you were to travel along one of these curves, you could quite literally travel back in time. In this bizarre situation, the entropy of the system decreases. Usually entropy wins out and things move towards disorder. Think about how a tidy room always seems to devolve into chaos over time. But sometimes the universe can actually move in reverse. When researchers used X-ray data from the Chandra X-ray Observatory to study a black hole that was actively consuming matter, they found that the material moved in unexpected ways. Specifically, the movement of the material suggested that time had reversed. It might seem confusing to imagine time moving backward, but it makes sense when you consider the laws of physics. One of the most fundamental laws of physics is conservation of entropy. This law states that entropy wins every time. But black holes might actually create exceptions to this rule. So while black holes are undoubtedly fascinating objects in space, they're also dangerous. If you fell into one, you wouldn't just be met with certain death, you'd be met with certain death that would result in you being stretched out into a giant noodle. So try to avoid falling into them, unless you really want to travel to the future, in which case you should just stand still near one. If you enjoyed this video, you can watch more of our videos by clicking the link on screen now. But please do not click the link to subscribe. Instead, consider hitting the subscribe button.